Forget Mars. Seriously, forget it for a second. If humanity finds real alien life in our lifetime, the smartest bet might not be a dusty red planet. It might be a moon hiding in the shadow of Jupiter, wrapped in a shell of ice like a locked vault. Because under Europa's frozen surface, scientists suspect there's an entire world, an ocean world, dark, pressurized, and possibly warm enough to be alive. Not alive like a movie monster, alive like nature always starts, tiny, relentless, adapting, and impossible to stop once it begins. And here's the part that should make your skin crawl in the best way. Europa doesn't just have water. Europa may have energy, chemistry, and time, three things that can turn a dead rock into a living ecosystem. So today, we're diving into Europa's hidden ocean, the evidence that it's real, what NASA is actually searching for, and the one question nobody wants to say out loud: if there's life down there, what kind of life survives in a black ocean under miles of ice? Now let's set the scene. Europa is one of Jupiter's largest moons, and at first glance it looks like a giant cue ball, smooth, pale, cracked with dark lines that wrap around it like scars. But those scars are the entire story, because Europa's surface is not calm and ancient like a dead world. It looks like it's been broken, shifted, refrozen, and broken again. Imagine Earth's Arctic, if it covered an entire planet. Imagine an ocean that freezes on top, but stays liquid underneath. And then imagine that frozen lid constantly flexing and cracking, because a giant planet, Jupiter, is literally pulling on the moon like a stress ball. Here's the basic idea. Europa is caught in a gravitational tug-of-war. As it orbits Jupiter, Jupiter's gravity squeezes Europa, then relaxes it, then squeezes it again, over and over, like kneading dough. That constant flexing creates friction inside the moon, and friction creates heat. And that heat is the difference between a frozen dead ball of ice and a place with a liquid ocean that might have been there for a very, very long time. And in the universe, a long time is everything. Life doesn't need comfort. It needs stability. A place where chemistry can run, where energy keeps flowing, where evolution has enough time to do what it always does: experiment. So how do we know Europa has an ocean if we can't drill through the ice and take a sip? We know because science is basically detective work at cosmic scale. Europa gives off clues, and those clues add up. One of the strongest hints comes from the way Europa interacts with Jupiter's powerful magnetic environment. Jupiter has an enormous magnetic field, and Europa moves through it. If Europa were just solid ice and rock, it would respond one way. But if it has a salty, conductive layer, like a global saltwater ocean, then it responds differently. And spacecraft measurements have suggested exactly that: something conductive under the ice, consistent with a salty ocean. Not a puddle, not a lake, a planet-scale ocean. Then there's Europa's surface itself. Those long dark lines, fractures and ridges look like the moon's crust is moving, breaking and healing. In some places you can see chaos terrain, regions that look like shattered ice plates that broke apart and refroze in a jumbled mess. That's not what a perfectly frozen world looks like. That's what you get when liquid or slush is close enough to the surface to mess with the ice from below. It's like looking at sea ice on Earth after it's been stressed by tides and currents. Europa is basically broadcasting the message: something is happening under here. And if you want the spice, the part that makes people lean closer, there have been hints of plumes. Think of geysers, jets of water vapor that might occasionally erupt through cracks, spraying material from the subsurface into space. If those plumes are real and reachable, that's the jackpot, because you don't need to drill through miles of ice. You just fly through the plume and taste what's inside. You sample the chemistry of Europa's ocean without ever landing. That's the kind of shortcut scientists dream about. Now, water alone is not enough. This is where most people get it wrong. They hear ocean and immediately imagine fish and glowing creatures and alien whales singing in the dark. Slow down. Water is step one. The real question is step two: energy. On Earth, life is basically an energy hunting machine. It doesn't want anything, it doesn't dream of anything. It just uses what works. Plants use sunlight, but deep in Earth's oceans, where sunlight never reaches, Life still thrives around hydrothermal vents, cracks in the seafloor, where hot mineral-rich water pours into the ocean. Entire ecosystems exist there, powered not by sunlight, but by chemistry. Bacteria convert chemicals like hydrogen sulfide into usable energy. And bigger organisms build on top of that. It's not pretty, it's not romantic, it's brutally efficient. Europa might have the same kind of setup. If there's a rocky seafloor under Europa's ocean, and if there's heat from tidal flexing, you can get interactions between water and rock. And when water and rock interact under heat and pressure, you can get chemical gradients, basically fuel. And where there's fuel, life has a reason to exist. That's why Europa is not just interesting. Europa is arguably one of the best natural laboratories for the biggest question humans have ever asked. Are we alone? So let's talk about what NASA is doing about it, because this is where the story becomes real. NASA isn't sending a mission to Europa because it looks cool in posters. They're doing it because Europa is testable. It's not just speculation. The Europa Clipper mission, designed to perform repeated close flybys, aims to map the ice shell, study the surface composition, measure thickness variations, look for signs of subsurface water, and hunt for chemistry that screams one word: habitability. Not life confirmed, habitability, the conditions that could support life. And that distinction matters because it keeps the story honest and the science strong. Europa Clipper is like a forensic kit. It's not showing up with a drill and a flag. It's showing up with instruments that can see in wavelengths our eyes can't, and sensors that can feel the environment like fingertips. It's looking for the ingredients: water, organics, salts, energy, and pathways between the ocean and the surface. Because even if Europa's ocean is alive, the only way we'll know is if the ocean communicates with the surface, through cracks, through plumes, through chemical deposits that get frozen into the ice like fingerprints. And here's where we take a hard left into the part that gets under your skin. If Europa is habitable, that doesn't mean it's friendly. In fact, the more habitable it is, the more unpredictable it becomes. Because life doesn't stay simple forever if it has energy and time. On Earth, simple life dominated for a long, long time, and then complexity happened. Slowly, then all at once. Now imagine a world where life evolved in complete darkness, under enormous pressure, in an ocean capped by ice so thick it isolates the ecosystem from the universe. No sunlight cycles, no seasons, no easy surface access. What does evolution build in a world like that? What does predator mean in a place with no light? What does camouflage look like when nobody has eyes? Maybe life stays microbial, maybe it stays simple, or maybe it becomes something we don't recognize because it evolved under rules our brains never had to deal with. And even if it's only microbes, that's still a universe-changing discovery. Because the moment we find a second independent origin of life, anywhere, we stop being a miracle and start being a pattern. That changes religion, philosophy, science, and our place in history. That's why Europa is such a big deal. It's not just another cool space topic. It's a direct attack on the idea that life is rare. Now let's address the elephant in the room. If Europa is so promising, why haven't we confirmed life already? Because Europa is hard, it's far, it's cold. Jupiter's radiation environment is intense, and Europa's ocean is hidden. This is not a gentle world inviting visitors. It's a locked box inside a storm. So scientists do what they've always done. They take the long way. They measure, they compare, they build models, they test hypotheses, they get closer step by step. It's old-school craftsmanship, patient, methodical, because the universe doesn't care about our hype. And that slow approach is exactly why this topic is perfect for your channel, because you can deliver the mystery without lying. You can say, here's what we know, here's what we strongly suspect, here's what we're about to test. That creates suspense that lasts, not clickbait that dies. So what could actually be under the ice? Let's paint realistic possibilities first. The simplest scenario: microbial life. Single-celled organisms using chemistry to survive near the seafloor. They could form mats. They could create localized ecosystems around vents. They might never evolve beyond that if conditions remain stable but resource-limited. And if that's the case, the biggest alien part isn't how scary it looks, It's the chemistry. Life there might use different metabolic pathways, different chemical tricks, but it would still follow the same brutal logic. Harvest energy, replicate, survive. A slightly wilder scenario. Europa's ocean has enough energy and nutrient cycling for more complex life, maybe something like small multicellular organisms, drifting and feeding, sensing their world through vibration, chemical gradients, electrical fields, or pressure changes. On Earth, even in dark oceans, complexity finds a way. The question is whether Europa's ocean has the right balance of energy input and stability. Too little energy, and complexity can't sustain itself. Too much instability, and ecosystems struggle to build. But Europa's tidal heating could provide a steady baseline like a heartbeat. Now the third scenario, the one that makes people obsess, is that Europa has active exchange with the surface, meaning stuff from the ocean occasionally reaches the surface and freezes into the ice, and stuff from the surface might sometimes get carried downward. If that's true, then the surface chemistry could hold traces of what's below. Salts, organic molecules, maybe even patterns that suggest biological processes. Not a smoking gun, but a trail. And here's the part nobody wants to admit out loud. Europa forces us to rethink what alien means. Most Hollywood aliens are basically humans in costumes. Europa aliens, if they exist, would be shaped by a completely different environment. No sunlight, no sky, no stars, no fire, no easy metallurgy. If intelligence evolved there, big if, it wouldn't look like us. It might not even build technology the way we define it. In a dark ocean under ice, what does civilization even mean? Maybe intelligence never evolves because it's not favored. Or maybe it evolves in ways that don't leave obvious artifacts. Again, speculation, but useful speculation, because it reminds the audience how vast the possibility space really is. Now let's tighten this into the strongest emotional core of the video, fear and wonder together. The fear isn't that something is waiting for us. The fear is that the universe might be full of life, and we've been staring at empty skies because we've been looking in the wrong place. Europa tells us to look down, not up, into oceans, under ice, into environments where life can hide from our telescopes for billions of years. And that is a terrifying thought if you really absorb it. Because if life can thrive unseen under a moon's ice shell, then the galaxy may be packed with biospheres we can't easily detect, and we might be surrounded by living worlds without knowing it. So what happens next? The next chapter of this story is data. Maps of Europa's ice shell, measurements of surface composition, searches for hotspots, thinner regions, and potential plume activity. And every new piece of data will either strengthen the case for habitability or force scientists to adjust the model. Either way, Europa is going to stay a headline because it's one of the only places where the question, "Are we alone?" might actually get answered with evidence, not vibes. And now I'm going to hit you with the punchline that makes this topic work so well for retention. The scariest part isn't what we might find. It's what we might not find. Because if Europa has everything, water, energy, chemistry, time, and it's still sterile, that's almost worse. That suggests life is rarer than we think, that the spark is not automatic, that even in perfect conditions, the universe might stay silent. So Europa is a coin flip with cosmic stakes. Either we find life and we rewrite history, or we find nothing and we're forced to ask why the universe is so empty. So here's your final question. The one I want you to answer in the comments because it tells me who you are. If NASA offered you a seat on a mission to explore Europa's ocean, but it's one way, no return, would you go? A. Yes, worth it. B. No, Earth is enough. And what scares you more? Jupiter's radiation, the miles of ice, or the idea that something has been alive down there for 1 billion years and never once saw a star? If you want more episodes like this, cosmic mysteries, real science, and the future of exploration, subscribe, because the next decade is going to get weird in the best way. And Europa? Europa is just the beginning.